All right, ladies and gentlemen, welcome to another introduction series, TLDR introduction series. Let's get that brand in there, right? What we're going to be going over today is TypeScript. What is it? How to get started? We're going to be even talking about the lint config and setup, and we're going to be talking about the major parts of TypeScript so that you know what to expect and what it all contains. So what is TypeScript and why should we use it? Superset of JavaScript. It was built by Microsoft, so it's being maintained by Microsoft. It's an open source project, more or less. So you have a lot of the community contributing to it. It's one of Microsoft's open source items that they now are going in an open source direction, which is pretty cool. At the end of the day, what you get back is regular JavaScript. One of the benefits to writing TypeScript is it tends to be less error prone. We're trying to apply static types to a dynamically typed language, and that eliminates some error, while the cons to that, it's adding a little bit more development time. Now, you could argue that development time is made up because it lends code to be more readable and thus more maintainable as time goes on, we have seen as developers. So what are we going to be covering? Well, we're going to showcase how to get started, how to assign types on variables, how to assign return types on functions. We're going to be talking about classes a little bit, although that's more of an ES6 item. We're going to be talking about string enums and number enums. We're also going to be talking about interfaces, intersection types, briefly about access modifiers, and then we're going to be talking about how to set up lint so that if you are doing TypeScript and you want your code to be more readable and maintainable, how you can make sure that it's even better in adhering to the latest standards. So that's what we're going to be diving into. Let's go ahead and jump right in. Hey guys, are you thinking about going to a coding bootcamp? If you are, might I recommend Dev Mountain Coding Bootcamp. You can check them out at devmountain.com. I've seen one of their campus in Salt Lake City, in Provo, Utah, and it was a beautiful campus. And they're unique in the aspect that you can get up and go today, right? So they include, in their tuition, they include housing. So it's quite literally a block away. You walk to and from campus, which is really nice. You're going to be there with a bunch of other people who are trying to be developers. So check them out at devmountain.com. All right, so to get started in TypeScript, first thing you're going to want to have is a node installed if you don't already. You can use the current or the latest. It doesn't really matter, whatever works best for you. It's all going to work. And then from there, I'll be using the Visual Studio Code text editor. You can use whichever one you want, but oftentimes people ask me what text editor I prefer or what I use. This is what I use for quite a few reasons. I like the extensions. I think it's very clean. The IntelliSense is great in it, and they also have a debugging tool, although I don't use it very often. So to get started with TypeScript, the first thing that you're going to need to do, now that you have Node installed, is go ahead and run this command. I'll be using git bash. If you have another terminal, you can use that as well. It doesn't really matter. So we're going to install TypeScript globally. That's what this G is. That's basically just going to mean that we're going to have access to the TypeScript commands moving forward in our application. This will take just a second, and let's go ahead and open up our text editor and get started. All right, so now that we have a project open, let's go ahead and create a new file here. To create a TypeScript file, all you have to do is, instead of creating a JavaScript file with a JS file extension, we're going to be using a TS. In this case, we're just going to call it example.ts. And now we have access to TypeScript, essentially. Now, whether it will compile or not, that's a whole nother story. But let's talk about how we might use TypeScript, for instance, in a very basic way. In JavaScript, when we would potentially create an array like so, we'll call this example, we would then go and set this array, and we could have maybe some numbers in it. Now, the JavaScript itself is going to say, hey, I see this as an array, no big deal. But you'll see now when we hover over this, it actually is inheriting a type here of a number array, an array of numbers, right? Now, this is called implicit typing, where when we're instantiating an object, it's going to look at it, and if it can inherit its type, there's also explicit typing where you can say, look, I just want to actually tell it exactly that this is going to be a number array, or perhaps it is going to be an array of several things, including booleans, right? So true. And you'll start to see right now the power of TypeScript where, hey, this is supposed to be a number array. We have instantiated the type and saying, look, cannot, you're going to get this error here saying, look, you're trying to do something to a number array that isn't a number. And one way that we can modify this is to add a or property as well as use any. And we'll talk about what that is right now. Okay, so sometimes because of the nature of JavaScript, when we're dealing with a dynamically typed language, and we're trying to make it a little bit more static and start assigning types, is we'll have arrays where we may not have all the same data type. So one way that we can handle that, and this is with input and output, we can use the or operator. In our case here, it's just a single pipe, like so, and then we'd say number or Boolean array, right? Now, what this does here is to say, hey, we are expecting an array. It could be number values, it could be Boolean values, either one, but it couldn't be, for instance, a string value, right? We're throwing in something like that. That's not going to break it because those types don't exist in this array. Now, let's go ahead and just get rid of this, and there's this any property I want to talk about as well, where any essentially is the way of doing the old school JavaScript to a degree, right? So all we're saying here is that this is an array. The values in it could be anything. We can also go ahead and assign any directly and say, look, this may change, this may not be good, this may be a down the road, if this was a let, this may actually go and become a string, and that would be okay in our instance because we have said that it is of type any. Now, if we said this was an any array, we'd get an error here, and we'd say, look, this is not assignable. You can't make a array a string. It just doesn't make sense, and we don't want that. And that's the power of types, to give you an idea of, hey, how to prevent things like that. It's also going to stop you from doing sort of crazy things if you're caught up in the moment where, like, hey, I want to do example.map, and then you return an array and you can do some stuff, right? But if you try to call map, let's say we actually type this all out, element, blah, 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 right? And right here, we return element +1 or something, right? And let's say this was a number array right now, that would work, and we'll go ahead and get rid of that Boolean. So we could get a new value here, set the ex2, and we instead say, you know what, I want to change this here to a string. I'm going to say this is a string, and I'm going to set this equal to an empty string. You're going to catch this error here where it say, hey, this ain't right? There is no map. Map does not exist on type string. It only exists on type object. So what happens here is we don't have to wait for our code to run and compile, and then hopefully this function fires off, and then we get a console log error. Our Visual Studio Code and the IntelliSense and TypeScript is intelligent enough to tell you, hey, we have an error. Let's look at what happened here in regards to our types and be able to fix it so that we don't have to have those errors go into the code. Now, so far we've talked about assigning types to variables, but you can also assign types to functions as well, right? So let's say we have a function called add, and it has a num1 and a num2. And what we want to do is return num1 plus num2. So not only can we assign it on variables, assign types on variables, let's go ahead and zoom this in a little bit. We can also go ahead and assign it on parameters where we are expecting a number here and we are expecting a string here. For instance, maybe we're going to move it to a number or a string. So we now can assign that. But not only that, we can say in this function we expect it to return a number, throwing a colon on here as well. So now this function is a lot more detailed. It gives you a better idea of, it's more descriptive in terms of what this function's actually supposed to do and sort of the type metadata here, if you want to look at it that way. And we have some checks in here. So where if we say, hey, let's return it as a string, it's going to say, hold up, Dylan. this type number is not assignable string because this isn't working here. So maybe you'd go in and you'd say, you know what, I need this as a number. Thanks for reminding me, and now I'm going to convert it to a string. So you have that additional detail to a function as well as checks to write cleaner, more descriptive code that's easier to read and maintain. All right, one of the great things about TypeScript is everything that we've talked about is optional in TypeScript. It's just another way of types are optional. Now you can write in the TSLint, and we'll showcase TSLint in a little bit later, how we might be able to make it not optional if you wanted to. But by default, TypeScript is optional, which means everything we're doing, you don't have to do. It's additional, and I think you should because it's shown to be better code in terms of less errors going in production. But what you need to remember is TypeScript is just a superset of JavaScript. It's just JavaScript to the next level, essentially. And so say we wanted to compile this down, and that's what would happen. Typically, you'll be working with like Webpack in a production environment, and it would just take your TypeScript files and compile them to JavaScript when it does your build that goes out and is actually being used in production. And so in our case, our production application is just our example here. So how might we manually do this so that we could see, hey, I actually want to see that it is just JavaScript that's happening here and nothing crazy. We're just assigning some additional data to JavaScript. Well, we can use this tsc command, which you'll have if you finish installing the TypeScript package we did earlier, and then you name the file, right? So in our example here, we would do example. We're already in this folder using our terminal here, .ts, and you'll see a second later, we now have this example.js file. Notice how there's no types. Notice how nothing has really changed except the fact that we removed our types from this, and it has compiled it to something that the browser, your browser, knows and can work with. So keep that in mind, is what we're writing in TypeScript is we're adding additional things to provide context for development purposes, to write cleaner and better code. But at the end of the day, JavaScript itself is a statically typed language that doesn't fully understand a lot of the more complexities when it comes to types and object-oriented programming. So you can see this is to me, TypeScript is very readable, but even more readable when it compiles just down to JavaScript. So let's say for whatever reason you don't want to create a TypeScript file and you're not ready to make it, but you just want to do maybe some type checking in your code. What we could do here is we can use this / and go ahead and throw @ts-check, and you'll notice there's some other ones. There's ignore, that essentially lets you ignore type checking on that. There is I don't even know what no check does. I don't know, ignore that. But ts-check here, and this will say, hey, let me just do a check to see if there's any errors in your code right here. So let's say that we wanted to we had a number, for instance, where we said, hey, let y equal 5, and then normally you'd say, yeah, let's go ahead and map that. And that's what we want to do. We want to map something, and then we want to have an element here, and we want to return true or something like that. And it's a, hey, does not match on type number. The only reason that shows up is because we have our @ts-check here to say, hey, treat this JavaScript file as a TypeScript file so that we can at least make some checks that go along with it. It's not going to add more to the readability of the code, which is equally important, but at the very least it's going to say, hey, are there any clear errors? And in this moment, guys, if you're writing JavaScript, I would encourage you to have this on here so that you can sort of, hover over this and say, look, map does not exist on type number. And you're like, oh, let it click in a little bit why that is, and you might pick up a few things that way. So that's ts-check, which I think is really important. So enums are something that's new to JavaScript, and where let's say we wanted to store a set of data that reference something, and like we wanted it to be the same throughout the application. One way that we might be able to do that is with a number or a string enum. We're going to go ahead and create a new file here, and we're just going to call this example.enum.ts, and we're going to export here a enum And this that we're gonna, what are we gonna call this? We'll call this our enums enum. And what's gonna have in here is, let's go ahead and call this num1, and you'll notice that by typically when you're dealing with enums, it's going to be an all cap enum name as well as all cap properties. And so we'll call this num1, and then we'll call this num2. And what this is going to be able to do, if we go ahead and import this into our TypeScript file here, and this is what do we call this? Our enums enum. We're gonna import enums enum from example enum. Now we'll have access to it, right? So what this is going to do is say, look, whenever we instantiate nums enum.num enum num1, this is essentially going to be equal to 1, and this one's essentially going to be equal to 2. Excuse me, I went off the trail there. This is actually 0 and 1 because we never start anything at 1 and 2. I was like, that's weird. Why did I say that? But you'll see here that this is essentially 0 and 1. Now we are setting the values here, but even if we delete these values like so, our number enum here will still have those values. And so we can now assign an enum as a type as well. So let's go ahead and say we want this to be a nums enum, and we want this to be a nums enum as well. And what we want to do here is just add those two numbers. So what we could do is, let's say we want to call this function add, and we're going to pass in nums enum.num1 and nums enum.num2, and now we're getting those values from the enum. And if we actually try to just pass in a number here, which pass in 3, I'm surprised that actually worked, because we should be passing in just a nums enum, but it gives you an idea that we should have that. I think if we had a TS lint, this would be a little bit more strict. I think it's being lenient because it's a number type. But what we would get after we compiled this, right? So let's go ahead, and we already talked about how to compile with the tsc command, and it's going to build it. Let's go to our example.js. You also notice that I think it's doing it for all of our folders in the area. But you'll see here, this is a lot more complicated JavaScript. But for us to get a similar item of what we've got in our example enum TS right here, which is a very readable, much easier thing to understand, this is actually what we would have had to do to be able to use it, which is kind of crazy, right? Because I don't know what that's doing at first glance. That's craziness. But here, it's a little bit more intuitive, right? Granted, so part of TypeScript is actually taking new JavaScript and compiling it to older versions so that even though it's less readable, it is more functional, and it's not going to break on bootleg browsers like Internet Explorer. So here you'll see we'll add these numbers together, and if we're to go ahead and let's run Quokka, for instance, on this TypeScript file, and save and everything, and we console log. Let's minus out a little bit. We console log the return of this add statement. You'll see that we get 1 because this is 0 and this is 1, and it's getting those values from our enum. Now if we were to change these values in here or there, it would reflect it because we're importing this. But that's how we would create a number enum. Now you can also create string enums. These are a newer addition to TypeScript. One reason you might have this is, let's say that you have a drop down that's never going to change, but you want the values to be all in one location, and you want them to, the user's going to select them, and maybe at one day you'll edit them and you're using various files. You could use an enum for that. I've done it with like country codes and things like that, and currency codes, and where I wanted to keep a list of it. So you could, all you have to do here is now set this to a value. This could be like hello, and this could be goodbye. And now you've created an enum that's going to break our code, right? Because well, in our example TS, that JS file hasn't compiled yet, but we now have a string enum that we can reference as well. You can also define local types as well. Now there's sort of global types you can define, and those are more so called interfaces, and we'll showcase that in a little bit. But let's say we wanted to define a type that we're going to only use in this file. We can use it with the type command, and we'll just say, we'll call it num example, and this is going to be equal to an object with a property, and this is going to be num1 of type number, and this will be num2 of type number. Now we're not assigning values here, we're defining a type. So this is the key, and this is the type of the key. There is no value. We are creating a type here with this type keyword. And now, instead of using our enums like we were using before, perhaps we wanted to modify this to only take in one value, and that value would be, we'll change this to nums, right? We want it to reflect what our code is here, where our value would be our num example. And now when we try and target this value here and we say nums, you'll see that when we hit this dot, the num1 property and the num2 property type exists because we've defined it in our num example type. So we could do nums.num1 and nums.num2, and then of course we have to go ahead and if we want to throw a value in here, we have to throw a value in here that makes sense, right? We have num1 and then maybe that's 1, and you'll notice we're still getting error because we don't have all the values in here to showcase that. But now that we do, and it matches this type, everything's hunky-dory and we're good to go. So that's how we would define a type. Now, as I mentioned, this type here is good only in this local file. Now, a better way of defining a type, and sometimes in the TS-lint, and the standard seems to be to get away from defining types and more so define interfaces. So we would do it like so. We'll say num example dot interface dot ts. Now this is just a file naming convention that I typically follow, but we want to export a interface. Usually interfaces are denoted with an I in the name of the class to let everyone know that it is a interface. It's not required, but we're going to go ahead and go with it. Nums example. So now that we have that, we could go ahead and pass in an object here, which is num1, and that's a number. And then num2, and that's a number. And you're saying, hey Dylan, this is very similar to what we were doing just a moment ago with the type, and that is true. However, types are declared within the file, and this adds a little bit of a readability issue, as well as we want to keep our code dry. We don't want to repeat ourselves. So if there's ever an instance in which we would need to use this interface again, essentially this type here, we can, while we can't reuse types. So that's one way, one main difference between interfaces and types. Really, types are essentially being deprecated at this point in time. So I would say stick with interfaces if you're looking to do that. So there's also access modifiers, which are an object-oriented thing that's new to JavaScript as well, because we don't really have them, and they aren't really real in the sense of like, hey, this is a development access modifier. It doesn't really matter once it all compiles down, but it's equally as important, and eventually they may come to exist as static types will eventually come to exist in JavaScript in one way or the other. So let's say we have a class here, and we'll call this example.class.ts. Classes are something that got added into ES6, and we have a great way of creating classes in TypeScript as well. So it's very similar. Export class so that we can use it if we wanted to, right? And our class, we'll just call this example class, and we're going to create some properties. By default, if we don't assign anything, we say, hey, what do we want property? Let's say this is a person. Instead of example, we'll call this our person class. And what might a person property be? It might have something like a first name, and that might be a string. And then we might have something like a last name, and that might be a string. And then we might have something like an age, and that will be a boolean. So we've defined our class here, which looks very similar to an interface at this point in time, because we haven't added all the items that a class essentially allows us. And by default, these are what are called public properties. What public means, and you could put them on here, and typically I like to be more descriptive with my code. Some people will say I'd rather just look at the code and be able to see that that's what it does. But these are public properties. That means that the user, when they're clicking on a page, can access it, and that other parts of the application can access it. There's also things called private properties. Private properties, and let's say age, we'll say bank account. All right, nobody wants to share that. And this will be a number. This is something that within your application you can use, but the user who would be consuming the application, the client, wouldn't be able to call this function. That's really it at the end of the day. And so these are usually functions that other functions are going to call to hide some of your code, and properties for that matter. There's also protected as well, which essentially means that it's going to be inherited from another class. In this case, we don't. That's the only way you can access to it. I wouldn't worry too much about that. But there is another great one, which I call read, which is read only. So in our case, first name and last name. Once we set a first name and a last name, it's not likely it's going to change, right? So we want to have the read-only access modifier, meaning that once it's set, you can't reset this elsewhere. You can't update this elsewhere in the code, because this is a read-only property. It can only be read. It can never be written to. So those are some TSLint access modifiers. And of course, if you're not familiar with you know, constructors, you can pass in data and set these properties in your TSLint class as well. So you would do something like, oh, well, this dot first name is equal to data dot first name. And then you could create public, or, you know, public example, public functions, or you could create private functions as well as, you know, protected. So these are how you might use them on functions as well. So I want to talk about decorators a little bit. These are an experimental part of JavaScript. They eventually may make their way into it. They're currently in TypeScript. In Angular, they're used pretty extensively. And I just wanted to give an example. We're not going to talk about how creating a decorator and all that sort of stuff, because it's a little academic when we go into it. And honestly, I haven't found any use cases in my own personal, like vanilla JavaScript, where I need to create a decorator. But they are used in Angular, so I think it's worth mentioning. So a decorator is usually denoted by this @ symbol and then this a word. In our case, it's the component decorator. And this, what the point of this is it will normally go before your classes, and it adds some metadata that maybe your class is going to need to be able to perform and use. And stuff that's not going to change. You know, in our case, it adds a selector. It adds a place where this is going to load in the view, and then add some CSS files that are going to be with it. So you can make a decorator just store about any data. They connect and do things. But I wanted to bring it up. We're not going to create it again, but I think it's worth just mentioning. All right, let's talk a little bit about intersection types, just a little bit more of an advanced thing. And I honestly have never used them, but again, hey, this is a video where we're trying to learn, so let's add some stuff in here to use. So let's say that we imported our interface that we created earlier. I'm going to go ahead and import, what the hell do we call this? enums example from /num example.interface. So what we can do here is we can actually merge items together, merge types together. One thing to be careful of is if you are overriding property values, which is why it's usually frowned upon when you're doing this. But in our example, we have a num1 and num2 properties. So let's go ahead and close that, jump back in here, and let's change this to num3 and num4 so we don't have any issues here. But what we can do is let's define a value here, and we can actually create a new type where we say this type, and we'll call this intersection. Type intersection is equal to the enums example and the num example type that we defined as well. And what this is essentially going to do is combine those two together and allow us to have those values. So when we go ahead and we type intersection here, or in section, I guess, what it's going to expect is that we have num3, and this is, you know, throw a number in, and num4, and we throw a number in as well. So you can combine types as well, although never found a reason to do it. Something you can do. Just be careful, I guess, is my word of caution. Now, hopefully by now you've kind of seen the power of TypeScript, and we're going to take it one step further. We've covered everything I wanted to cover about TypeScript thus far, but another thing that I wanted to talk about is setting up TS-lint. If you've never used a linting tool before, what it basically is, like JS-lint as well, is a way to say, hey, I want my code to stick to a standard format, and so that there's a space here. This would be a linting error. That's dirty code, and that there's no semicolon here. That would be a linting error. It's dirty code. And make sure that I'm writing code like a developer should is really the point of a TS-lint or a linting option. We're going to go ahead and get you started so that you can start writing code that when employers look at it, they can see that is of a professional nature. Now again, I'm using Visual Studio, so where you can get started is to search for TS-lint here. You'll see it has 4.7 million downloads. It's probably one of the most used items there is. So just go ahead and install that into Visual Studio Code to get going here. And we'll talk a little, and we're going to have to reload, and we'll talk a little bit about what this is going to do for us at the end of the day. Okay, after you have the extension installed, what we're going to do is we're going to use the TS-lint -init command to install. Okay, now that we have the TS-lint extension installed, we actually need to install the TS-lint npm package globally. So we're just going to do npm install -g. Remember how we did TypeScript? In this case, it's going to be TS-lint. So once that's done installing, should just be a second here, we are now going to go ahead and create a TS-lint file using TS-lint -init. And you'll see here, when we jump back to here, we have this tslint.json. Now, what this is basically going to give us is it's going to have some default rules and a bunch of other things that we can override to set what rules we find important when it comes to our linting. You'll see already when we jump into some of our files, we already have errors here, and it'll tell you when you hover over it, trailing white space. In this case, it means that we have actually spaced out manually some spaces here that the compiler is saying need to exist, and that we don't need that. So let's delete that, and then you'll see here, what is this? This block is empty. There should be no empty blocks of code, right? That shouldn't be a thing. So it's telling us like, hey, put code here or get rid of it. Same thing here. We can have that, and we could absolve this by putting a comment if we needed an empty block, or there's ways to disable TS-lint. So you also see like we have a white space right here. This is not clean code to have these spaces. Now there's a lot of TS-lint rules, and you can override them, and in some cases you'll see here like another one. All files should end with a extra line at the end. There's some compile reasons for that, but that's the convention. But you can hover over this and it'll tell you. So there's a couple things that you can do. You can do //tslint :disable, and this will disable all the TS-lint tracking while you're developing from that line down in this folder. So again, you can go and set some custom rules for your TS-lint. They're going to have the recommended ones, and that's what I recommend. If you're using TypeScript, you should probably be using, unless you're working in a production environment that has a different standard for whatever reason, what the language itself recommends. It's Microsoft who maintains TS-lint. It's Microsoft who makes TypeScript. So that's my personal opinion. But if you did want to set rules or override rules for your TS-lint, this is the page where you can go and get all of it, and you can see there are a ton of rules of what you can modify here, and every new iteration of TypeScript has additional rules as they are getting stricter or modifying some things and going from there. So keep that in mind when you are working with TypeScript, that TS-lint. And if you're saying, look, Dylan, you didn't sell me on TypeScript. I don't know how I couldn't, but you didn't sell me on the importance of it. But if you're just like, I'm sticking with JavaScript, fine. That's completely fine. You should probably be doing linting in your JavaScript, and you can get a JS-lint or an ES-lint package. You can see here ES-lint has 7.1 million downloads and is being used quite often as well, and it works similarly. It's just a little bit of setup, so I do encourage you to do that. But as always, guys, I hope you enjoyed this video. I hope you found it helpful, instructional, and I hope by the end of it you can get up and get going with TypeScript. I've actually been loving it for the last 8-9 months I've been working in it, and I plan to continue working in it. So don't forget to comment, like, subscribe, share, support me on Patreon. Click that notification bell so you can see when I get here, and hopefully you're already subscribed, and now you just watch whenever I put these out. So I'll see you guys next time. Bye. Okay, today's question is from David Aparcio. He says, "Hey Dylan, in your opinion, what do I have to do to find a solution to a problem faster? I ask because I've started to make challenges on code fights, and I usually take a lot of time to solve the problem. I don't know how to do it, and see your solutions. How can I improve my coding skills like you? Greetings from Venezuela." Well, shout out to the Venezuelan homies of the world. But David, a lot of people ask this question. Algorithms are something you just have to practice. There are books that you can read, such as Cracking the Coding Interview. I'm currently reading it, trying to get better myself. But at the end of the day, it gives you an opportunity to practice a language and think about problems that you may not typically have to in the modern workplace. A lot of times you'll be making back office tools and things like that. So there is no real shortcut. I will say that try to visualize it and draw it out on a whiteboard helped me out a lot when I was just getting started, and writing pseudocode is another option. So when you're solving algorithms, try and take that approach with it. But at the end of the day, you're just going to have to practice. Hey guys, thanks for watching the video. Don't forget to subscribe and hit that notification bell so you can see when I post new content. And if you're interested in any of my Udemy courses, I currently have some on JavaScript and 2 on Angular, and I'm constantly adding to them and updating them. It's been a lot of fun. So if you're interested in that, there's links in the description below where you can save some money in the process and help me out. See you next time.